All right, so let's tackle the dot product. So if we apply a force to an object so that the object moves, we see that the work is being done by the force. In the chapter Introductions to Applications of Integration in Volume 2, Calc 2, the textbook, on integration application, we looked at a constant force and we assumed the force is applied in the direction of motion of the object. So under those conditions, work can be expressed as the product of the force acting on an object and the distance the object moves. In this chapter, however, we've seen that both force and the motion of an object can be replaced by vectors. So in this section, we developed an operation called the dot product, which allows us to calculate work in the case when the force vector and the motion vector has different directions. The dot product essentially tells us how much of the force vector is applied in the direction of the motion vector. Dot product can also help us measure the angle formed by a pair of vectors and the position of a vector relative to the coordinate axes. It even provides a simple test to determine whether two vectors meet at a right angle. All right, so our dot product can allow us to calculate work when the force vector and motion vector have different directions. The dot product tells us how much of the force vector is applied in the direction of the motion vector. Okay, so the dot product can also help us measure the angle formed by a pair of vectors. And gives us a test to determine whether two vectors meet at a right angle. These are all the things that we can expect to see in this section. All right, so let's talk about some of its properties.